Blue Dolphin here, and in this video we're going to be creating partitions and file systems in Linux. Let's get into it. Jumping right into things here, we're going to be creating partitions and file systems in this practice lab. And our tags are partitions, file systems, MBR, and GPT. So I already know that MBR is the master boot record, and this is more of a legacy format, but we find it on a lot of I think IoT devices just because it's lower overhead and it's a little cheaper, whereas GPT is newer and more relevant. All right, so let's start this practice lab here. So it says our exam objectives, same as the previous video. We're still working through them. Install a boot manager, create partitions and file systems, and maintain the integrity of the file system. But these are going to be covered across the next several videos to kind of conclude the overall objective here. All right. Let's go ahead and click next. And we have the same topology. So we have our CentOS and our Ubuntu server, and they're already started up. All right, exercise 1, create partitions and file systems. The hard disk on a system must be partitioned before you can use it. Information about these partitions is recorded in the MBR, master boot record, and GPT, GUID partition table on the drive. In this exercise, you will understand how to create partitions and file systems on a disk. Awesome. So the learning outcomes say after completing this exercise, you'll be able to log into a Linux system, manage MBR partition tables, manage GPT partition tables, and create various file systems. Awesome. So let's go ahead and jump over to our Ubuntu server and just clear the terminal here. And the first task is managing an MBR partition table, which stands for master boot record. This is a legacy boot record table. All right, each hard disk contains one MBR partition. That makes sense, wouldn't be able to boot into anything if it didn't. It is the first sector of the disk and is not large enough to hold more than 4 partitions. These partitions can be primary, extended, and logical. There can be a variation on the number of primary and extended partitions that you can define. For example, you can have 3 primary partitions and 1 extended partition. Else, you can have 1 primary and 1 extended split into 3 logical partitions and many more. Very cool. To manage the MBR partition table, perform the following steps. Awesome. Be happy to. So it looks like we're going to start off with the parted command. So if we go sudo parted, enter the password. It just says okay, so let's shorten the command down and keep it simple. So the parted command, if we don't do any of the flags or fancy stuff, it just says, hey, using dev SDA, which we kind of expect because that's like the default and basic hard disk location in Linux. So if we now we're actually in the parted interactive terminal here. And we could call U, for example, and say unit compacts, or we could call S, or no, I think it's going to be P. Yes, looks like P actually prints out the specifics. Very interesting. All right, but let's look at this command a little more. So let's go parted -- help. Man parted. Just curious if it's, so this is a partition manipulation program. And the description reads, parted is a program to manipulate disk partitions. It supports multiple partition table formats, including MS-DOS and GPT. It is useful for creating space for new operating systems, reorganizing disk usage, and copying data to new hard disks. This manual page documents parted briefly. Complete documentation is distributed with the package in GNU info format. Cool. Okay, let's go ahead and work this command a little. So we're going to do sudo parted dev SDA, because that's where our default hard disk is always going to be mounted to, our storage. And let's see what the U does. It wants us to call USP. So what do these do? U does, well, I don't really see it here, so I don't know what U does. Let's try with just U. Units. So it's asking about units, okay? And then the S is script, so never prompt for user intervention. And then the P is, I'm going to assume that is just print for display the partition table. Okay, very cool. And yes, looks like U is set the default unit to unit. All right. Now that we know what those basic commands are, we'll run it. And here we go. You can see our basic partition table. And we can see where it starts and the size within the memory blocks. And it's a primary ext4 file system with the boot flag. All right, very cool. I guess it looks like over here in the practice lab, it actually tells us what the U, S, and P were for. Okay, very cool. So step 3, looks like we can also list the partition using the fdisk command. Very cool. Let's clear our terminal and try out fdisk. Let's go. First, let's man fdisk just to learn a little bit about it. And it is another binary to manipulate disk partition tables. And the description reads that it's a dialogue-driven program for creating and manipulating of partition tables. It understands GPT, MBR, SUN, SGI, and BSD partitions. So a little more than the parted command. Block devices can be divided into one or more logical disks called partitions. This division is recorded in the partition table, usually found in sector 0 of the disk. In the BSD world, one talks about disk slices and a disk label. Interesting. All partitioning is driven by device I/O limits. The topology, by default, fdisk is able to optimize the disk layout for a 4K sector size and use an alignment offset on modern devices for MBR and GPT. It is always a good idea to follow fdisk's default as the default values. All right. Then it says, note that part X provides a rich interface for scripts or print disk layouts. fdisk is mostly designed for humans. Okay, what's part X? Let me try this. Is this even on here? No, it's not. All right, well, I'm going to pretend that didn't happen. Okay, so let's go sudo and use our partition manipulation program, fdisk, list what we have on our SDA. As you can see, we have our block storage, just like we'd expect. Very cool. All right, let's clear that. And then the practice lab asks that we now list, again, the partitions on our second drive, so on B. So we did A, now we're doing B. And you can see it has just looking here, interesting. Okay, so on B we have 2 partitions. So SDB, oh no, we have our 2, our 2 partitions, SDB and SDB2. Perfect, great. Seems straightforward enough. Next, we're going to run the command without the tac L. Interesting, and it says, this command displays the list of options to work with. Okay, so if we just do dev, SDB, and we pretend we're a total noob and don't understand what we're talking about. I see. So it gives us the interactive prompt. And we can type M for help. Oh, wow. And from here, we have a lot more options, as you can see, once we get into this interactive prompt here. Very cool stuff. Okay, well, our practice lab says press M to see the list of options. We've done that. Then it says, to display the existing partition table, type the following command, P. That was pretty easy. All right, step 8. Currently the disk has 2 partitions and no free space. You'll first delete a partition and then create a new partition. To delete a partition, type the following. Go figure, D for delete. Simply enough, we'll delete this partition. And then it's going to ask which one. And it says you have 1 or 2. Bam, we'll do number 2. And it's deleted. Awesome. Okay. Step 9 says you're prompted with the message that the partition has been deleted. To display the existing partition table, all right, type P. Then you can see we now just have our 1 partition table. Easy enough. Now we're going to create a new partition. Awesome. So we'll go N for new. And we're being asked, do we want to do a primary or an extended? We'll do a primary partition. And my cat is here to say hello. Hi there. And we will enter 2 for partition number 2. Because it'd be confusing if we did 3 or 4 without a 2. All right, what's next? Next is, I guess we want to determine our first sector. So we'll just keep the default of that long number. Okay, and I guess we'll accept the default again. And it says partition 2 contains a ext4 signature. Interesting. Well, what could that mean? Well, let's see here. Looks like the practice lab actually accounts for this, and in step 15 it says you're prompted that the disk contains the ext4 signature. All right, we'll type yes. We're going to remove the signature. Oh, look at that. It actually just removed it. Awesome. So step 16 reads, till this point, you've created a partition table in the memory. To save the table, you write the table. Here's my cat. My cat is attempting to walk across the keyboard. Okay, so it looks like we are writing the table to the memory of the device. So if we don't write it to the memory, it probably won't save. So to write our changes, we're going to do W to write. All right, and I can't see because my cat's in the way. Okay, so we have written our changes to the partition table, and my cat is still attempting to climb me. One moment. Okay, let's see what's next here. Moving on to step 17. Now that we're prompted with an error, this is because the dev SDB device is in use. Okay, fair enough. To verify the new partition table is created and that the new partition on SDB, what we're going to do, as we learned, sudo fdisk-l. And you can see it is indeed there. Although I think I made a mistake and I actually was supposed to, I wasn't supposed to accept a default value. Okay, so let's go ahead and actually recreate this. So this is good practice. We'll go sudo fdisk. We're going to get the interactive prompt. All right, I think my microphone was just cut out for a second there. So our last sector seems to have prompted us again. Okay, I guess hex code. Okay, I guess this is interesting. So it looks like it's just letting us know that, hey, you know, I don't know what it's letting us know. Okay, so let's type P to see our partitions. Interesting. Okay, so we can see our partitions. They're there. Awesome. So we created a third partition within our GPT partition. Awesome. Okay, and then I guess the big thing here is to write it. So I think if we were to exit this interactive prompt, it would actually not save the changes. So when we write it, final checks complete, about to write GPT data, this will overwrite existing partitions. I see, okay. So you could come in here, play around, and if you don't write it, none of it's saved. And it looks like it says, okay, writing new GUID partition table, GPT to dev SDB. The kernel is still using an old partition table. The table will be used at the next reboot or after you run part probe 8 or kpartx 8. All right, that, yeah, sounds good to me, I suppose. So I guess we actually, do we have to complete the reboot then? So it says you can complete the reboot or continue to the next step. Well, I think we'll just continue to the next step. And then we can try the reboot. So let's do fdisk list. Oh, crap. Wait a sec. I did what they told me to, but now it's not good. We're going to be stuck in this weird loop. Okay, let's go new tab. And I don't mind things like this because making mistakes is really a very unique way to learn. And let me make this full screen so no one has to hurt their eyes squinting. Okay, let's do sudo fdisk-l dev sdb. And we should see our 3 partitions, and there they are. Awesome, look at that. Okay, step 10. So we are now going to use the make swap command. We can also create the swap space on a partition. However, before you proceed with creating the swap space, you need to unmount the partition. All right, cool. So in order to make a swap space on the partition, we have to unmount, and we're going to do this on SDB2. Oh, I see, it's umount. Okay, dev SDB2. I guess that worked. Let's go sudo fdisk list dev sdb2. Yeah, it's not mounted. There's no partitions. So if we were to actually look at something that had a partition, it would look like this. So we would see disk label and disk identifier, but we don't have a disk label. We don't have a disk identifier because it's not mounted, and we don't see the device here. Cool. All right, let's create a swap space. So let's go sudo make swap dev sdb2. And this says warning, wiping old ext4 signature. All right. So it looks like we have our swap file. Huh, cool. All right, let's move on to task 3. Create various file systems. You can create types of file systems such as ext2, ext3, and ext4 with the makefs command. In this task, you'll create an ext file system on the SDB1 partition created in the earlier task. To create a file system, perform the following steps. So we'll type clear. And we will create a file system. So we'll sudo make file system. Let's see what the -t does. So I'm just going to do tac help. T is type, all right? So sudo make file system -type ext3 dev sdb2. It says it contains a swap file system. All right, well, that's okay. Let's create one anyways. It says it's discarding device blocks. It's creating a file system, super block backup stored, allocating, creating a journal. Cool. All right. I guess that's that. We have a swap file now. So I guess if we wanted, we could increase the swap size. And what that would do, if I understand correctly, again, I'm still trying to learn all this, is it would move everything from the RAM when the RAM is full to the swap file. So it's kind of like your like backup RAM or like the archiving of RAM until that information is passed on to the hard disk where it's stored and then hopefully cleared from RAM. But if you have bad processes or your Reaper isn't working, then perhaps your RAM is taken up and your swap file system is taken up. And we know this happens. If you use a Windows machine, you haven't rebooted it for 30 days, just take a look. You'll see that you have all these stagnant processes taking up your RAM. All right. So next step, we are going to verify the type of partition being used. So we're going to go sudo ls-blk, so list block and -f. What does the -f mean? Let's use the help command. It means, oh boy, output info about the file system. All right, so we're going to go sudo list block file system. Right. I have no idea what these loops are, but I see our SDA and our SDB. So one of our partitions is 21 gigs, the other is 9 gigs. Cool. Very cool. Okay. And then I guess our SDB ext4 is not being used at all. Awesome. Okay, so there's no screenshots. We completed all the lab setups. All right, let's go ahead and hit next. And now I guess we'll enter the questions. So what is the number of MBR partitions contained in a hard drive? So with MBR, okay, we're going to redo these. So with MBR, it's 1. And I'm just thinking, I want to do a sudo fdisk-l dev sda. And let's just try the sudo parted command again, dev sda. But I think we have to do units, don't prompt for scripts. And then what was the third one? I don't know, let's see what this does. Oh yeah, P for print output? Yes, okay, and it says this is the primary, and it's a virtual disk. And when we run parted, the MS-DOS means it's the MBR. So I think if we were to run this again, we were to say, all right, show me SDB. It says the backup GPT table is corrupt. So that will be sure. Great. Okay. Let's type okay. All right, you can see there, yeah, partition table GPT. So okay, cool, okay. So what is the maximum number of primary and extended partitions you can define? Well, we know it's 4. What command allows you to display existing partitions on a disk? Of course, we know that's going to be fdisk-list dev sda. There it is. Next question is going to be, when default gdisk command, what is the default you would use? We know it was 8300. How many partitions does GPT allow you to create on disk? Unlimited. I guess I'll submit this report. All right, I think that's a wrap. So we'll hit the complete button. Back to the title, that's a wrap, and I'll see everyone in the next video using various disk management tools.